Hello, everyone, and welcome to today's webinar, Commercial Spaceflight, the Future of Humanity. Before we get started today, I would like to go over a few important items so you know how to participate in today's event. Firstly, you have joined the presentation listening using your computer speaker system by default and are muted. You will have the opportunity to submit text questions to today's presenters by typing your questions into the Questions tab of the control panel. You may send in your questions at any time during the presentation, and we will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded, and you'll receive a follow-up email within 24 to 48 hours with a link to view the recording. And finally, to get important WAC information throughout the day, please refer to our Instagram page, which is at World Affairs Con. However, for now, given that information, I would now like to introduce our speaker for today, Ms. Janet Ivey. Janet Ivey is the CEO of Janet's Planet, a program committed to enriching the lives of children through educational content on topics regarding space, science, history, and health. Located in Nashville, Tennessee, Ms. Ivey has received 12 regional Emmys, 5 Gracie Allen Awards, and a STEM Florida Award for her children's series. Additionally, she is also the president of Explore Mars, is on the board of governors for the National Space Society, is a Buzz Aldrin Shared Space ambassador, and is a spokesperson for Enterprise in Space. She has joined us today to answer our curiosity-piquing questions regarding space exploration and commercial spaceflight. She'll be discussing the future of the industry, the importance of space exploration, and humanity's future opportunity within the cosmos, including habitation of Mars and more. Ms. Ivey, I hope you're doing well, and I'd like to thank you so much for giving us the opportunity to speak with you today.
Thank you.
With our interview,
Thank you for having me.
To start with our interview, I would like to touch upon, firstly, on your personal career. And that is something I found extremely intriguing about you, is that through your Janet's Planet, you managed to combine two unique disciplines in the form of the arts, communication, public speaking, and entertainment with the sciences, an undoubtedly differing subject. Where did your passion in each of these fields come from?
I think I was born with a sort of love of entertaining or presenting and acting and that kind of thing. My love of science happened because of an amazing 5th grade teacher named Miss Ernestine Yarborough. And she was the one who introduced me to the solar system. And she and Miss Carolyn Davis on a Friday night long ago in a small town in West Tennessee had a star party on the playground. And I just remember watching two amazing ladies look through this telescope, point us towards, constellations like Cassiopeia and, planets. And I was hooked. And so I think from the time I was 10 years old, I've always loved space, solar system. That was also the year that Star Wars kind of premiered. So, I'd been a fan of Star Trek. I love Star Wars. So again, I was pretty early when my love of science. Luckily, that same 5th grade teacher kept saying, Janet, science isn't just for the boys, it's for the girls. And along the way, even through high school, I had some amazing teachers that said, here I was in band, chorus, and drama, but I was also continuing to take, the higher math and chemistry and physics. I wasn't good at it necessarily, but I was very intrigued by it. And I kept, even throughout, early kind of like college and my early careers, like I still love space. I ended up, kind of getting performance jobs, performing with and for children. And I started looking around, and at the time, Bill Nye the Science Guy in the mid-90s, that and Beekman's World were the only really the only children's shows touting science. And I thought, I will take my love of performing and my love of the solar system and Janet's Planet. And that's how that began.
Yeah, and as one interested in the sciences myself and the audiences as well, I'm sure we could all definitely relate to that. And that kind of leads me to my next question, which is how your series Janet's Planet educates the youth on topics regarding science, space, and more. And In fact, in an Explore Mars report, you state that science is the greatest adventure story of all time, as it inspires students to dream beyond their house, their town, and their own earthbound experience. So why did you, similarly kind of related to the last question, but why did you choose to invest your career in science education?
I think because it's like I love learning. I am naturally curious. It's like if I don't know something, I love to go, "Oh, I don't know anything about that. Tell me more." And so I wanted to impart that to kids and to tell them that smart is one of the most amazing things that you can be, curious and scientific, because Carl Sagan even said we're all born natural scientists, and then sometimes we don't always have those people in our lives that are pushing us forward in that pursuit. So for me, it was like I thought I could do this kind of children's programming, I could do this, but for me, it was like, let me combine the things that I love. I would encourage anybody out there, whatever you would like, whatever science topic you might want to be an influencer, or, share or communicate something about, do the thing that you love. Because to quote Rumi, whatever you are seeking is also seeking you. Whatever interests you is going to interest somebody else, and find that audience and speak to that. But I just felt like I also chose space. Well, the cool thing is planet rhymes with Janet, so that was a that was awesome. But for me, it was like space was always this amazing thing when we realized that our very essence, it's like from the carbon in our DNA to the calcium in our teeth to the, iron in our blood, that we are made from the same elements that exist in the hearts of stars. That it's like, as I thought, as we look out at space and realize that we are part of this grand mechanism and intrinsically related to these kind of like cosmic and chemical compounds, that we would also always revert our eyes back to earth, realizing that, you know we are part of everything that is out there, but also, wow, what an amazing blue little ball, this amazing spaceship Earth that we live on. Perhaps, not only looking out will make us a bit better and hopefully better crewmates of spaceship Earth. So yeah, so I just had this inkling. I think there was also always a through line, even as I was everybody's favorite babysitter. There was always a through line of children in my life some way. Funny enough, I was never able to have children myself, so I just go out and find students and talk about space and science with them.
I find it like amazing how this all relies on your drive for just curiosity. And yeah, now moving on to our plenary topic on space exploration. My first question relates to the growth of these like new companies like uh, Virgin Galactic and SpaceX, and like with the launch of these new like satellites, such as the Transporter One mission and the recent launch of Falcon 9 and Dragon. Where do you see these companies kind of going in the near future and accomplishing?
I mean, it's been exploding for a long time. When I really, when I started and really was pushing and getting to know people, even, you know, 12, 15 years ago, the explosion of commercial companies has been profound. People were talking about it, and then you saw things like SpaceX and Blue Origins and Virgin Galactic, Virgin Orbit come online. But you also have some really quiet little companies that you're going to hear more from, like Firefly down in Austin. They've got amazing plans. There's Axiom. There's, again, what I find interesting is that everybody has like this interest in space. It's like it's estimated that in in a few years, in the next several decades, space tourism, the entire space business, space economy is going to be worth like $3.2 trillion. So I think there have been futurists for a long time looking at there's got to be, you know, there have been these billionaires who go, this is where I want to go. But what we've seen even as of late with commercial and government, kind of partnerships, the Crew One Dragon, and even the Astro Doug and Astro Bob launch back May. It's like that was a beautiful relationship between NASA and SpaceX. And, there are other companies like, ULA has been a launch partner for a long time with NASA. So I as I see it, and as the things I listen to, it's like the way that we're going to go back to the moon is going to be with global partners, global governmental partners like Australia and Canada and Japan and Luxembourg and all of these great places, ESA, and then it's like we're also going to have some of those commercial partners be large parts of that. I mean, as we look forward to the future, you can see that quantum computing is probably going to be online with some of the satellites that are deployed in the next 10 years. How is that going to reshape how we can go to space and go further? There was just an article released a day or so ago with a woman who is working with this kind of plasma propulsion. And again, it's almost kind of, you can't keep up with the data that is coming each day, or the announcement of like something yet. I heard the CEO of Firefly talk about that. 60 years ago, folks were thinking about nuclear, powered kind of propulsion, things like that. So they're trying to figure out how can you do that safely, et cetera. But again, we're always building on what people were dreaming of, 50 years ago, 60 years ago, 100 years ago. You go back to From Earth to the Moon by Jules Verne. It was written in 1865. 104 years later, there are actually astronauts on the moon. In Jules Verne book, they don't actually walk on the moon, but there are striking similarities. And you go, wow, how do you create the future? Well, or predict the future. You go out and you invent, you imagine, you sit and innovate, you create it, you claim that you know how to get there even if you don't, and you have this idea and you let your imagination follow. And some people out there might be going, well, Janet, you've got to have it based in science, of course. But remember, I generally work with kindergarten through about 10th grade. So those are the students. So about 6 years old to 16. And so a lot of times it might look like child's play when I'm asking them to build a lander out of a paper, a plastic cup, or we're using origami to learn how engineers are, kind of trying to figure out how to deploy everything from satellites to solar panels to, big star shades better. And so while it might look like craft time, there is this bit of, if I can get a kid excited about what they could create with a plastic cup, or a paper cup and a straw, perhaps that leads them on a journey of investigation that eventually leads them on to going, well, if this would work, maybe this would work. And that's what I'm talking about. It's like, how do predict the future? Well, you go about creating it. And I think that's what some of these amazing commercial companies are doing. Granted, they have, some resources behind them. Most governments are a bit tied to the fact that it's like that is supported by taxpayer money. So they have to be a little more judicial about how those money is spent. They, like the green test run, the NASA's last green test run got a little bit of flack going, why did it shut down? Why didn't it go for the full 8 minutes that it was scheduled? Because if the engineers noticed any anomaly, my guess is they were like, hey, before we destroy something, we're going to shut it down. We're going to check out and make sure, is this an anomaly? Is this something we need to perfect? Because they don't have the resources to simply dispose of that and build it again. So there's a bit of like checks and balances, I think, or more checks and balances per chance in the governmental sector. But I think when we go, we're going to go back with multiple commercial partners, multiple global partners. And in essence, the moon and Mars won't be just one nation. It's going to be a multitude of nations and represent all of humanity.
Yeah, and you just mentioned it that something else that's super high up on the news relating to astronomy. It's not only these commercial space companies, but also humanity's just their future on like Martian soil, just as you said. And especially that they're given the goal by accomplishing that by like I think it was like 2033. And recently, to assist in that, NASA launched their Mars 2020 rover Perseverance, which is a huge accomplishment in the industry. And how critical do you think that the results we get from this study are in determining whether we could actually send a human there?
Oh, perseverance, no doubt, is like the success of it really paves the way for human exploration. I mean, think about it. It's going there with different instruments and kind of like more perfected instruments that are going to kind of with their big super cam laser and everything, they're going to be able to pulverize, kind of get, it's kind of an extension of that Kim Cam operation on Curiosity. But, you know, they're analyzing a lot of the geology, pulverizing rocks to see what chemical compounds are here that might be harmful or, you know, detrimental to humans. And then they're caching those samples. And then the 2026 rover hopefully will go there and be able to, you know, a little spacecraft will manage to get those back. I think the biggest thing is that instrument MOXIE that is on Perseverance. That the MOXIE instrument for the, and you guys probably know this, is designed to take, you know, Mars's atmosphere is 96% carbon dioxide. It is designed to take that carbon dioxide and, you know, basically turn it into oxygen. And so we know that it's successful here on Earth. If it is successful on the red planet, it's a game changer. All of a sudden we can, you know, produce oxygen for life support for astronauts. We've got oxygen as a fuel source. We send a bigger MOXIE in a few years. And again, it's a game changing, you know, paving the way for human exploration. If we can generate enough oxygen for life support there, possibly for a return fuel, because it's, you know, megatons of oxygen required for a return mission. So in that way, it's like, it's an exciting time. It's like we're less than 2 weeks away. It lands on, I think it's 3:30 p.m. Eastern on February 18th. So everybody be watching that. But with every robotic mission, and there are many people who think we should just stick with the robots, like we can send it. But I think as humans, we have a natural inclination that we want to go there, hold it in our hands, walk around. Because think about it, it's like Spirit and Opportunity. They were only supposed to last for 90 days, and then they went on to last for many years more. But the distance that they covered was about 4.6 you know, kilometers or 4.6 miles. And it's like that, I could walk that, you know, in a day. And so when you think about how a human could pick it up, have like the improvisational skills to kind of go, what does this mean, without waiting that delayed time? Because again, you know, at this point, we don't have any mechanism that we can create faster communication. So you send the command. Now, Perseverance is preloaded with a lot of commands, especially as it relates to Ingenuity, the helicopter. Again, what a Wright brothers moment when Ingenuity gets deployed. It's even cool how it's tucked underneath Perseverance, but it's almost got this James Bond kind of arm trigger that's going to flip it, put it down on the surface. Perseverance is going to run for about a month or two, make sure all systems are go there. Then it will deploy Ingenuity, and Ingenuity will have about 30 Martian days to exercise about five missions. The first one is going to only go up to about 10 meters and then come back down. We just want to see, again, the real challenge for the team for Ingenuity was, can we create something that is, you know, kind of solve that physics problem of creating a mechanism that is, you know, heavier than air but can still fly. So they made the craft super lightweight. The roto blades like go 3,000 RPMs, faster than any speeds we've ever seen here on Earth. And again, it's a high risk, high reward mission. But if it is successful, we will have a Wright brothers moment. We will just have flown a rotocraft on another planet. That's going to be stunning and miraculous in and of itself. And then we potentially have the opportunity for drones to scour the area, again, making human exploration even safer, because they could go, oh, don't go over there. This is a good spot to explore. So, again, robots are needed. Listening again, I would highly recommend you guys investigating some of these smaller space companies, and Firefly's one of them, Axiom, and see their kind of plans. There is a plan. Some people think we should go to Phobos. Like, granted, we've got all of this debris and space satellites that are defunct. Right? It's very crowded. It's only going to get more crowded the more things that are deployed up there, and some of them simply don't work. So what do? Do we, I've seen a design for like a space magnet, and you could kind of like triage that, pull the junk, and do we just let it go and burn up in the atmosphere? Firefly's idea is that really for space storage, you grab any of that defunct material, somehow with a little mechanism that you sort of drag it out to Phobos at Mars. You store it on the top of Mars, and then when anybody, wow, I need a spare part here, and there it would be. So they would be solving and mitigating a little bit of the space junk that is encircling our Earth, and then potentially have some resupply and extra resources there on Phobos. There are people who think we should just go to Phobos or Deimos and stuff, and then go down to Mars after we've successfully landed there. It's a little easier to do that than on Mars. So, I what I really believe is that in our lifetime, especially in your guys' lifetime, and especially in the lifetimes of anybody in that is in elementary school right now, you're going to see people go back to the moon. You're going to see people potentially living cislunar. You're going to potentially, I think, see humans take the first steps on the red planet. It's going to be exciting. And then the question will be, can we sustain that? It's like, I've seen mission plans to go out there. It'll take you 7 months to get there at the prime times, right? And then spend a month and then come back. Well, that almost seems like, are you kidding me? You're going to spend, 7 months getting there, only spend a month, but then they're going, I don't even know if I'll have my Martian legs by then, after 7-month travel. But they're going, if you could sustain that, that's payload, that's food, that's like, how do you grow the food? So these are all things that I would love for you guys to think about if you're listening to this. How can I contribute? How do I create a vertical garden that can grow in space, that can feed the astronauts all the nutrients? Oh, maybe I should become a biomedical person, where I'm thinking about individualized medicine and nutrition, and I might need more potassium and electrolytes, and you might need more iron and calcium. And it's like beginning that idea of personalized medicine for those astronauts. How do I prevent any kind of like eyesight, vision loss because of the pressure that, microgravity, everything rises and puts the pressure on, some of those optical nerves. So one of those things, I just think there's so many opportunities. And if you haven't read it, my friend of mine named Robert Jacobson has written a book called Space is Open for Business. And if you are interested in becoming a space entrepreneur, head to that book, whether that is space farming, 3D printing. Again, somebody's going to have to be the culinary chef for these Mars meals. Think about how it's like meteorology. It's like, if we go to Mars, we're going to have to be able to predict what the weather's going to do, what the windstorms are going to do. How do we conserve power if a dust storm lasts for very long? So my personal belief is simply this: we are going. Just like we're going to go back to the moon, and whether that's 2024, 2026, 2028, we're going to go. And then the same thing for Mars. We're going to at least try it. And yes, robots, it's like maybe we do a 60-year plan, and it's, 10 years, we send robots there to create certain structures, another 10 years, and so it's more graduated. If you listen to the UAE, they've got a plan like that. They think we might be on Mars. Their plan seems a little slower than for those of us here in the U.S. and at Explore Mars. They think by 2100 or so, or in the 22nd century, there are folks at Explore Mars that have been working their entire careers for getting human presence on Mars to explore. So whether we stay a month, or we figure out a way that the astronauts could stay 3 months and then return home, I think it's happening. And how that happens all depends on governmental agencies, commercial and private industries, and the entire globe cooperating together and saying, this is for all of humanity. This is to prove that when we come together, we are better, we can accomplish great things. Because again, every mechanism needed to get there and sustain life potentially improves life here on Earth, whether that's creating space suits and that are impervious to radiation. Then we come back home and we solve cancer. So those are my hopes. And somebody listening could be like, she is really out there and is thinking too altruistically, or that it's too utopian. But that truly is my hope, that space, at the very essence of what it does, it unites people. We are all part of this great cosmos. We are all connected to each other, either biologically or chemically. You know what I mean? It's like, it's just this beautiful atomic kind of like energy between everything. And so my hope is that as we reach out and branch out and think about how humanity lives in space, works in space, does research, anything that we do out there, I pray ultimately improves life and improves peace and humanity here on Earth.
Yeah, I wish we could keep going. I would love to ask you more of my questions, but
Oh, I'm so sorry. I probably left zero time. I can talk all day because I get so impassioned. I'll just end with this. I don't know if you've got a question from anybody that out there, but guys, there's only so much any one human knows. So find a good person, find a mentor, find somebody, reach out. You might get a ton of no's, but there's somebody out there who's going to say yes. And then you're going to tell your idea and they're going to go, hey, you come along, let's do this. And whether you're in grade school or high school or college or post grad or whatever you're doing, if you have a real vision for where you want to go in space, what you can do in space, again, Einstein said that if your idea is not absurd enough, then there is no hope for it. So dream great things, dream absurd things, because you guys will be the ones that will be able to say, yeah, we came up with this audacious plan, and by George, it actually worked. So I hope to see everybody on Mars one day. In fact, I'm hoping that all of you will provide a way for a granny to go to Mars. So look me up when you guys get ready to go. I'll be with you.
yeah, we have a few questions in the Q&A. However, this webinar is going to shut down in 3 minutes, so
Oh, I'm so
I
sorry.
no, it's all good. Just being conscious of time. Just want to thank you so much for coming. And before we end off, I just have a few important information for everyone attending regarding the conference schedule, and that is, once you leave today's webinar, you'll receive a survey on the presentation, and we would appreciate it if you'd complete that and provide your feedback. And again, you'll also receive a follow-up email within 24 to 48 hours with a link to view a recording of the webinar. And next, please navigate to your links hub on the website worldaffairs.ucc.on.ca to attend the following events. Immediately following this plenary at 10:20 Eastern, the programs team is hosting a networking session on Zoom, and this is an opportunity for you to meet other participants and bond over fun prompts in breakout rooms. Please refer to your personal schedule on the WAC website for the Zoom link. And finally, on behalf of the WAC team and our presenters, thank you so much, Ms. Ivey, for coming to speak with us today, and for all attendees for joining us. And have a great rest of your day.
Thank you. Thank you so much. Bye-bye.